Hey guys, we're going to do some practice with graphing and writing equations from written situations. So I just have a couple of example problems for you, and then you'll hopefully be ready to go. So the directions state that you need to make a graph of the function based on the following information. You need to add your axes, you need to choose an appropriate scale and label your graph, and then you need to write the equation for your function. So this is all part of what you're going to be doing. So this first example, the beginning value of the function is 3, and its value is 2 times larger each time. So if I want to write that sequence out, we've got 3, then multiply that by 2, 2 times larger, and that's 6. 2 times larger than that is 12. 2 times larger than that is 24, and so on. Okay, so as far as creating a graph, I'm going to switch colors here. Since I'm primarily I'm completely dealing with positive numbers, I'm going to go ahead and put my axes right here. Make as much use of the graph as I possibly can. Okay, and so then down here, I'm going to go up by ones because we're doing term values down here. So 1, 2, 3, 4, 5. Okay, term. And then on the side here, I may want to go up by something a little bit bigger because I'm going 3, 6, 12, 24. I want to get at least a couple of those on there. So I'm going to go up by 3s. I could have chosen, 2s, 4s. Doesn't have to be the first term, but that just seemed to make the most sense for this situation to me. The key is you want to pick a scale that lets you show off kind of the shape of the graph, and you want to make sure that you pick a scale that shows more than just the first term. Okay, don't keep it too small or make it so large that it doesn't really help you out. Okay, so the first term was 3, or maybe we should say the 0th term. We'll call this 0, 1, 2, 3. So the initial term, the beginning value is 3. It's right there. So then we go to 6, and then we go to 12, and then we go to 24. And that gives me a nice curve to show that doubling. Okay. Now the last step is to write the equation. So hopefully by now you recognize this as a geometric sequence with the first value being 3, and then we are multiplying by 2 again and again and again. So I'm going to put it to the nth power because that will represent that we multiplied by 2 0 times here, 1 time here, we multiplied by 2 twice here, 3 times 2 times 2 is 12, 3 times 2 times 2 times 2 is 24. Okay, so this is my equation, and then of course I want to give it a function name, f of n, or you could have used x, t, any variety of variables. Okay, so that's this one. Let's try another one. So for this problem, same directions. The beginning value of the function is 3, and its value is 2 units larger each time. So a little bit different language. Instead of 2 times larger, it's just 2 units larger. So we have 3, and then 2 units larger than that is 5. 2 units larger than that is 7. 2 units larger than that is 9. Okay, so we have to kind of pay attention to the language so we know how this is growing. So again, we're dealing with positive values. I'm going to go ahead and put my axes over here. And this time I don't feel the need to go up by 3s necessarily for this. Sorry, that wasn't very cleanly done. Okay, but I could, but I don't think that's going to be as worthwhile. So I'm just going to go up by 1s on both axes. So 1. You don't want to label every single one. You could just skip every other one. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so the 0th term is 3. Then we go up by 2, up by 2, up by 2 creates a nice straight line. Okay, so that's my graph. I've labeled my axes. I can put down here term and here the value. Okay, so again, we need to create that equation. So function name f of n, the 0th term, so the y-intercept is 3, and we are going up by 2 for each one. And again, you could have used x or t, it all depends on what you want to use for your variables here. But up by 2 at 3, so just check that 0th term. 2 times 0 plus 3 is 3, 2 times 1 plus 3 is 5, 2 times 2 plus 3 is 7, 2 times 3 plus 3 is 9, so this does work. And that's what you're going to be doing in this particular set of the assignment. Okay, have a great day.